Alrighty, good morning, everybody. Happy Thursday. I want to thank you all for joining us today for our 7th tech webinar this year. My name is Anthony Connors, and I'm the Regional Field Engineer for the Michigan and Toledo area, and I'm going to be your host for today. Real quickly, I'm just going to go over a couple of things you might be noticing here if you're new to our types of events. You probably have already noticed this, but your camera and microphone have been turned off, and hopefully on the right side of your screen you should be seeing a Q&A feature there. If you have any questions that come up during the presentation, you can feel free to submit them there with your first and last name as the presentation is going on, and we're going to take some time at the end of the presentation to answer your questions. If you don't see that or it doesn't seem to be functioning for you, you can always email your questions to solutions.michigan@swagedoc.com, and we will add your questions to the list for our presenter today. But with that out of the way, I would now like to welcome back Aaron Sexton. Aaron is one of our account managers here who's been with our SwageDoc team for just about 10 years now. He's going to be taking us through the webinar today on system safety equipment. So without further ado, I'll now turn it over to Aaron.
Thanks for the introduction, Anthony. Good morning, everyone. I appreciate you taking the time out of your day to be with us this morning. So as we make our way through the next several minutes together, my goal is to help you gain a better understanding of what system protection means or system safety means. I want to arm you with a reliable method for selecting some of the proper components for your application. And we're going to cover some ways to overcome some issues that we've seen in the field, along with some additional component considerations that we'll talk about. So with that, we'll jump right into it here. So when I use this, the phrase system protection or system safety, you may have several thoughts or inclinations as to what that means. So just to keep us all on the same page here this morning, here's how we're going to define it. We're going to talk about it as safety, which we're going to talk about as meaning for people or yourself and your coworkers, personal safety. We're going to talk about it in terms of the environment, protecting the immediate area of your facility and the surrounding geography of your facility. We're going to talk about it in terms of quality, protecting the quality of your upstream sources and your downstream end results, whether that's a commercial use product, test data, etc. And then system protection or system safety, we're going to talk about in terms of production as well, protecting your equipment, such as pumps, regulators, storage tanks, analytical devices, measurement devices, etc. So we're going to take a deeper dive into some of the components used to accomplish system protection. This is obviously not an exhaustive list, so because we only have about a half hour this morning, so we'll just dive into a few specific items here today. So the first component we'll talk about is the relief valve. They come in all sorts of different shapes, sizes, materials, internal mechanisms, but they all serve the same general purpose, and that is to protect the system against catastrophic failure due to overpressurization in the system. You may oftentimes see the acronym PRV on spec sheets or on P&ID drawings. Just know that that is referring to a pressure relief valve. And relief valves are known as passive control devices. This simply means that they act on their own. There's no human interaction required to open or close once that relief pressure is set. It uses the tension from an internal spring to keep the valve closed under normal operating conditions, normal system conditions. But when that system pressure exceeds the spring setting, that's when the valve will open on its own. And there are a couple different types, or two primary types of pressure relief devices. There's an ASME safety relief valve, and then there's what's called a proportional relief valve. A safety relief valve, when opened by system pressure, this will dump the entire system media. Typically, these need to be manually reset, though, using a handle or a lever on the top of the valve. So they're not totally passive in that regard, because they do require a manual reset. However, a proportional relief valve, that's a slow opening device. It will only relieve enough pressure to bring the system back to operating conditions. And that will do that by itself and reset itself all on its own using the spring and the system pressure. So how do you select the right relief valve for your system? We are going to use the stamp method which is an acronym used to help us remember all the necessary parameters to consider. We've gone over this method before in previous webinars, actually one just a couple months ago, presented by Jamie Stiglich, and one a couple last year that we talked about hoses as well. So check those out on our website. Those are available there for your viewing. But as we walk through this, the acronym, the S, that is for size. We want to make sure that we're right sizing the valve to your system. We're going to keep in mind the flow required, the CV, which is a flow coefficient calculated based on the flow that you need. We want to make sure that the valve you're selecting will meet that flow requirement that you're going to need for relieving your system if needed. The T is for temperature. We want to make sure that the valve we're selecting the internal seal elastomers, internal components must be rated high enough to avoid any damage from temperature. The application is the A. We want to ask ourselves the question, is a relief valve the right device? Or the question, do I need a safety relief valve or a proportional relief valve? In this regard, you can consult site spec requirements. Each site may have their own different requirements, or you can consult any applicable industrial codes that are there for that. So making sure that the relief valve is the right valve for your application. M is for material. Media compatibility with the wetted components of the valve is vital to avoid any premature corrosion or loss of seal containment. And when I use the term wetted components, that simply just means that it's the components that are in direct contact with your system fluid. In a Swagelok catalog, when you look at the parts breakdown, all the wetted components will be listed in italics, just for a little bit easier selection there. All right. So next is the P, and that is for pressure. Be sure the valve is rated to handle the normal operating pressure and the maximum allowable working pressure of your system. This is key, obviously, but also in regards into setting the spring, so that the spring is typically set at your maximum allowable working pressure. But there could be some variables there, so just make sure that we're being considerate of our pressure needed. The E is for end connections. What size and type of end connections needed? Depending on the ports available in your system, you may need to adapt to a more standard connection and that's especially when you consider the last step is delivery. Will I get the valve in the delivered or in the desired amount of time that I need? So making sure that we're, the end connections that we have available will meet our delivery time as well. So keep those things in mind as we're selecting our valve. Go through that stamp method. And then some of the common issues that we see when we're talking about relief valves, one of those is that the valve is opening too often. One possible reason for that may be that your set relief pressure is too close to your normal operating pressure. In that case, you may want to set, or you may need to set the relief valve relief pressure higher, but only as long as that spring is rated for it, and also only if that doesn't exceed your maximum allowable working pressure. So make sure that you're consulting all those things if you're having that issue. Another issue you may see is leakage across the valve seat. When you know that valve is in the closed position for sure. You may need to see if there's any debris that's in the seat blocking that poppet from sealing. That can be an issue as well. So a couple things to look at there if you're having some issues with the relief valve that you're using already. And then some additional considerations when we're talking about relief valves. One of those being is your discharge containment. So when that relief valve opens, it is discharging your system fluid somewhere. Is it going to a flare system? Is it going to just go to atmosphere, back to the original source, or an overflow tank? We want to make sure that we're understanding where that fluid needs to go. And then if you're using a flare system or some other type of enclosed system to capture that discharge, you must take the back pressure into account when adjusting your spring and setting the relief pressure. With more back pressure, then the higher system pressure is going to be needed to open that valve. So something very much to keep in mind when you're selecting your valve there. And then another thing to consider is a manual override. You can see in the picture there, that red knob on the top. A manual override in a proportional relief valve allows you to press that and to use it in somewhat of a way as a safety relief valve, where that will dump your entire system. It'll override your spring and just open that valve completely, and that can be in case of emergency. So if that's something that you need in place, keep that in mind, and that type of device is available as well. All right, so we're going to move into check valves now. So check valves are also known as a passive control device. There's no manual actuation required. They're designed to allow fluid to flow in only one direction, and that's the direction that you intend it to flow. And their main purpose is to prevent backflow in the system. In doing that, we're helping to prevent contamination of your source fluid. Especially useful in systems where 2 or more fluids may be mixed together downstream. You don't want that mixture being able to come back to your original source and ruin that source. It also prevents backflow from damaging critical components, and often very expensive components. Things like pumps, you don't want impellers spinning the wrong way. That can be damaging. Protects things like injectors or regulators, monitoring devices, things like that. So they can be very key in protecting your equipment. A couple basic types of check valves. One of those being a spring-loaded check valve, which is kind of self-describing there. Uses an internal spring to assist in closing the valve. That inlet pressure must overcome the spring pressure and also the system back pressure to be able to open that. And we'll dive into that just a little bit more coming up on the next couple slides here. The other item would be, the other type would be the lift check valve. This is a gravity-assisted valve where the gravity assists in keeping that poppet closed. The inlet pressure must overcome the back pressure as well as that gravity. It's a very simple design. It has very few internal components, but something to consider, because they are gravity assisted, they must be installed horizontally, as opposed to a spring-loaded check valve, which can be installed in basically any position that's needed. So something to keep in mind there as well. So then how do we select the proper check valve? Again, we're going to go through that stamped method in making sure that we select everything, or spell out everything that we're needing in selecting our valve. One of the big challenges in selecting a spring-loaded check valve is with the pressure and deciding what spring to choose, what spring pressure to choose. The key to understanding that is in the differential pressure. That is the big key in that. So knowing the cracking pressure has a nominal value and a range. So you can see there from the first 2 columns that you see there. Your normal cracking pressure in the first column, that's the average differential pressure required to open the valve, while the cracking pressure range in that middle column, that's the minimum and maximum upstream pressure that's required to open the valve. And another thing to understand is your reseal pressure in the third column there. Your reseal pressure is dependent upon your system back pressure and the spring rating, overcoming the upstream pressure to be able to close that valve. Chris Kiesling, our operations director, he does a great job in explaining this in depth in one of our previous webinars as well. That's entitled Directional Flow. Go check it out on our website, michigan.swagelok.com. You can get a much more in-depth discussion and explanation on that there. So again, go check that out on our website. Directional Flow is the title. Okay, and then one thing I want to tackle is a question that comes up fairly often. That question is, can a check valve be used as a relief valve? Now, some may disagree with the answer that I have to this based on experience or other factors, but I'm going to give a very general no, that a check valve should not be used in place of a relief valve. And when you think about what we just talked about, check valves operate based on differential pressure. If you put a check valve in place to use for relief, once your system reaches that cracking pressure and opens the check valve, there's typically will be little to no back pressure to get that valve to reseal once your system has bled off enough pressure to get back to normal operating. And then it can become a constant open state and essentially become a system leak. And leaks can be very costly, as I'm sure we all know. Another way to think about it too is this way, like if I need to nail two boards together, if I'm putting something together at home, I'm not going to go buy a wrench to drive in some nails. I'm buying a hammer because that's what its designed and intended purpose is. And that's the same with valves. We want to use them generally, use them in a way that they were intended to be used and designed to be used. So if you need a check valve, use a check valve. If it's a relief situation, use a relief valve. And the one thing I'm going to jump into real quick, because they are in the same family as check valves, is what they're called excess flow valves. They're, like I said, they're very similar to check valves in that they are a passive control device and they are spring loaded. Unlike the check valve, though, these remain in the normally open position, and that is until an excess flow event downstream occurs, maybe a system rupture where you're losing containment. In that case, when that happens, the valve will close and then stop any uncontrolled release of your media. So just wanted to point that out, just because they are in the same family as the check valve. So excess flow valve. And if you need more help in definition or how that might be used, let us know and we'll talk to you about that. All right, and then the last item we're going to touch on today, and the third item here, is we're going to talk about filters. When used or when properly used, they help to maintain system cleanliness by removing particulates and in some cases even moisture from our system. If uncontrolled, even the tiniest of particles can cause some large problems. They can cause damage to equipment such as pumps. They can damage sensitive equipment like analyzers, regulators, gauges, sensors, etc. And then particulates can even stick to or gouge valve seats and O-rings, creating leak paths. And that's kind of what you see in that picture there to the right. You can see those flecks in that regulator seat there. Those can cause scratches, which become leak points, and then they can even prevent the valve from the regulator from closing. So make sure that we're using filters to filter out that particulates. They can also even help prevent damage to your product quality. We all know that the quality of our product that we're producing, whether it be for end use for sale to a third party or just even test data, having that particulate in there can definitely decrease the quality of our product, and that is not something that we want. So you can put a filter in place to protect against that. Filters also provide system protection by decreasing the risk of leaks, like we talked about in that picture, across valve seats and regulator seats. They can prevent clogs, and that's especially true in areas with reduced orifices. And then even in fire, especially true for oxygen systems. And then we'll have a resource available at the end that you can read more about protecting or decreasing the risk of fire in your system there, especially in an oxygen system. So things to keep in mind there. And then how do we select the right filter? If you've been paying attention, I'm sure you've already guessed it. We're going to go through that stamp method again. It can be very useful in many different applications. So in walking through these steps, you should determine, it should help you determine the filter style you want, which can be based on the like the maintenance plan that you intend to use. For instance, an inline filter like the top two pictures you see there, those have to be taken out of the system to be serviced, while a T-type, like the bottom picture shows there, those allow the element to be replaced without removing the filter housing from your system. So something to keep in mind there. Something else you should know as you're walking through these steps, you should know what exactly you're filtering for. Are they metal shavings that may end up in your system from a process upstream? Is it sediment from your system fluid? Is it bacteria? A myriad of different things that you want to filter for. So make sure that you know exactly what you're wanting to filter. Okay. And then in knowing that, you'll be able to select the right micron size needed for the element within that filter housing. Selecting the right micron size for your system can trip people up a lot. And when we use the term micron, it simply refers to the nominal pore size that you would see in the element, whether it's a sintered element or a strainer element that you see. 1 micron is 1 micrometer, which in other terms, it is 1 millionth of a meter, so it's a very small measurement. And then the smaller the micron size, the smaller the particulate it will filter out. So knowing what you're filtering for will help you select that micron size accordingly. And then as a general rule in selecting your micron as well, your filter size, to help prevent clogs in the system and help prevent the filter itself from clogging, the micron size should not be any larger than the smallest orifice of your system. So anything larger than that, if you're allowing a pore size that will allow larger particles to get through, you could end up with clogs in a small orifice in your system down the road. So make sure that you're keeping that in mind. I apologize. Sorry about that. A little slip of the mouse there. So a common issue that we see could be abnormal pressure drop or reduced flow downstream of that filter. This is typically caused by a clogged element or a clogged filter housing. What we want to do in that case, change the element, see if that solves it. If that clogging continues to be a problem, if it happens too fast or too often, you may need to consider changing your maintenance plan to do that more often. And if that's too laborious, you may even need to reevaluate the micron size being used. Perhaps your particulate could be larger than the micron size that you need, and you could go a step up in size there. So keep that in mind if you're having some abnormal pressure drop or reduced flow downstream of that filter. Okay, and then starting to wrap up here, allow me just a little pro tip for using the stamp method. Put together a sheet similar to this, like what you see here, and I'll leave that up for a moment. And use it to log all the information that you're going to need, that you'll need in that product selection, whether it's a relief valve, a check valve, or a filter. And you can use it in many different other areas as well, so don't stop just at those. You can use it for ball valves, you can use it for hoses, regulators, etc. So it can be a very handy sheet for you, and then keep a log of those sheets, and you can keep them in a binder or a folder on your computer. That way you can refer back to those when you need it, especially for maintenance plans, or if something's been around for a long time, you can look at those sheets and help you identify what's in place there to be able to replace that and service it. Okay, so just try to keep a selection sheet like that. All right. So as I said before, some additional products to consider that we just don't have time to go in depth on. A few of those would be a bleed or a purge valve. These are for manual pressure relief. So they are a type of relief valve, but not a passive control device. These actually require you to open it manually to relieve system pressure. Another item could be a fusible fitting. You see there in that center picture on your screen there. Those are used in fire protection, or they're used for not in pressure protection, but in temperature protection for overheating of your system. And then a dielectric fitting you see on the left-hand side of your screen there. Those are for electrical current protection. Helps you protect sensitive equipment from electrical current that may be present through your system. So again, not an exhaustive list, but some things to consider and think about there. So wrapping up for today, as our time is coming to a close here shortly, we talked about some selection of components to help increase your system protection. We can do that during the design phase, during upgrades or outages. And what we really want to do is make sure that we have the safe operation of our system. We're protecting safety of our people, protecting the quality of our product, protecting the environment around in our facility and around us, and we're protecting our production, our equipment itself from any damage. So those are the things that we're going to consider in system protection there. So with that, we'll go into any questions that may have come up. Anthony, any questions there?
Yeah, thanks, Aaron. We got a couple questions here actually throughout the presentation, so that's always great to see. I do want to remind everybody that if you do have any questions, we got that Q&A feature on the right side here. You can go ahead and submit them, and we'll add them to the list here and try to take up some time before we hit 10:30. But if we jump right into it here, Aaron, first question we have is from Brett, and Brett is asking, what relief valve end connections offer the fastest lead time?
Well, it's a good question, and I can only speak obviously for swage lock items. So anything a valve with a threaded connection, MPT connection. Typically, a valve is going to have a male and female, so those are going to have a fairly fast turnaround time. And then also ones with a swage lock end connection that uses the ferrule, the two ferrules and nut on there. So being able to adapt your system to accept either one of those, that'll give you the fastest turnaround time for delivery with a relief valve.
Yep, great answer there. Moving on here, we got looks like next question is from Zach, and Zach is saying, I have a relief valve cranked down all the way and it still opens too much. What can I do with it?
Okay. Yeah, that is an issue that we see every once in a while. So if in that case, if you're having to crank down that relief valve and still having issues, two things to check. What is the intended relief pressure that you're needing? And is the spring that you have included in that relief valve rated for that pressure? If you're cranking down all the way on that, it may be that your spring is rated too low. And you may have to go up in size in your spring. Another thing also, make sure that there is a spring in there included inside that relief valve. There have been cases where either that spring gets removed or it doesn't come with the spring. You have to buy the spring separate. So open that up, make sure that there actually is a spring in there to use.
Yep, we've seen that a couple times here.
Yes, absolutely.
Moving on here, next question is from Chris, and Chris is asking, stating, it's kind of a doozy. I have a tank with a check valve on the outlet connected to a hose. The check valve isn't letting any liquid out of the tank when it gets down to a 3-foot level. It's a 1 psi cracking pressure check valve. I guess he's wondering why it's not working.
Okay, so I think that would go back to what we talked about in differential pressure. You've got that 1 psi cracking pressure check valve, but keeping in mind that is a range. The cracking pressure is where you see just the very start of flow. So if it seems like it's an atmospheric pressure or kind of a water column pressure, that water that's remaining in there, that 3 feet of water, whatever, I believe that's what he said in the question, is not applying enough pressure to that fluid to be able to open up that valve. So you may need to go with a lower cracking pressure. You may need to instead of just allowing water or gravity to push that out, applying maybe some pressure on top of that liquid to increase the internal pressure of that tank to open that valve, or that check valve maybe need to be moved to a different spot in the system. So a couple things. So give us a call, shoot us an email. We'd love to talk to you a little bit more about that and help you mitigate that occurrence.
Yeah, great. Moving on here, Jeff is asking, what happens if I get buildup on a lift check valve? Can it be cleaned? Thanks.
Okay. So check valves in general, they can be cleaned either by removing the element and changing that out, or you can back flush those to clean them out depending on the media and the system that you have set up. A lift check valve is a little bit different. You can't backflow those because that'll just push the poppet closed. The nice thing about the lift check valve is that it's a union bonnet design. So essentially a nut on top of that housing. You unscrew that nut. It's only a few components on the inside of that nut. Open that up. You can take out the poppet, clean that out, the best you can, in whatever way is necessary. Put that back together and then test it, make sure it's working. So that should be a fairly easy way to clean that out with the way it's designed.
Great. All right. Moving on here. This one's pretty interesting. Anonymous is asking, often filters resemble check valves. Is there an easy way to tell the difference if the number on it isn't easily visible?
Okay.
I can kind of take this one here, I think.
Yeah.
This is a pretty good question here. So we know that the lift check valves and the filters both have to be installed horizontally. And there's a key difference in those two. In fact, is which way the actual head cap is faced. So if it's pointing up or down. If it's pointing up, you know that that's going to be a lift check valve because you're going to need the gravity of the pop to go down and close off and seal that lift check valve. While as if it's a filter, you actually have that head cap pointing downward. So you're actually able to unscrew that and drop out your filter through there, clean it, and screw back in. So short answer would be just to check which way your head cap is facing, if it's up or down. Up, lift check valve, down, filter.
Okay.
Okay, and we're pushing up here on 10:30 here, so unfortunately it's all the time we have for questions. I know we got a couple more here left. We'll be sending and responding to those shortly after here, but thank you all for your questions. Just as some follow-up stuff, we'll have some good reference material going out to you guys, and as always, we want you to reach out to us if you need any help. You can schedule a virtual or an in-person meeting with our field engineering team at michigan.swagelok.com. We have our upcoming webinar here next month, which we'll be covering steam tracing. Winter's coming right around the corner. It's better to be prepared now than later. That'll be on August 19th at 10 a.m. Also, some interesting things that we want to point out is that we'll be out in the Midland area next month hosting a live training session covering tube fitting and bending essentials. It's going to be August 24th at 2021 at the Holiday Inn in Midland. You can email us or scan that code right there to register for our class here. And for any questions, concerns, or feedback regarding this webinar, you can email us at solutions.michigan@swagelok.com. And again, I want to thank you all for joining us today. And for more information about our webinars, please visit our website at michigan.swagelok.com. Thank you all and have a great rest of Thursday.